Now in this video we are discussing derived trigonometric ratio problems. So let's start with this example to know what we are about to deal with. If sine theta is equal to 3 over 5 and theta is an acute angle, that is an angle less than 90 degrees, what is the value of tan theta? Okay, so for this we said it's derived because for the solution we have to draw a right angle triangle. When we draw a right angle triangle, we are going to say this and then assign maybe assign theta to any side of the triangle. So this is the opposite, right? And this is the hypotenuse and this is the adjacent of this angle assigned here. You could assign here, you could assign any side of your choice. Okay, so this is the hypotenuse, this is the opposite, this is the adjacent. Now, for sine of angles, remember that sine, when we write out so, we have that the sine of an angle is equal to the opposite over the hypotenuse. So, sine theta, whatever theta is equal to, this 3 is the opposite. So, as this is the opposite of our angle, we have to say that this is 3 over hypotenuse, so 5. So on this side that we called our hypotenuse in this our triangle, we call it 5. So remember, they are asking us what is the value of tan theta. Now you'll be asking, is this the only type of triangle we will deal with? Remember they said if it's an acute angle, that is an angle that is less than 90 degrees. And for every right angle triangle, the other two angles are angles that are less than 90 degrees. So that is why it is safe for us to use a right angle triangle. Okay, so back to the question. They asked us for tan theta. So tan should be the opposite over the adjacent. Now for this our triangle, we don't know what this adjacent side is equal to. So what we are going to do is we are going to use the Pythagoras theorem to solve for this adjacent side. Pythagoras theorem just simply says that from Pythagoras theorem we have that the hypotenuse squared, so 5 squared, is equal to the other side squared plus the other side squared. Now what do we call the adjacent? Let me call the adjacent x. So x squared. Now to make x the subject formula, we have that x squared is equal to, now just 3 squared moves over to this side. So we have 5 squared on that side already. Then 3 squared comes over to become minus 3 squared. Now we have to get the square root of both sides so that x is equal to 5 squared, that is 25, 3 squared, that is 9, 25 minus 9, that is 16. So the square root of 16, which is equal to 4. So we have that this adjacent side we called x is actually equal to 4. Therefore, coming back to what we are solving, what is the value of tan theta? So we have that tan of the angle theta is equal to adjacent over opposite, which is, no, opposite over adjacent, which is TOA. TOA, opposite over adjacent. So 3 over 4. And that is our required answer. Here we have another question. Given that tan x is equal to 5 over 12, what is the value of sine x plus cos x? Okay, so just like we saw in the previous example, we have to draw a right angle triangle to now assign this fraction to the sides. So I'm having my right angle triangle here. This is angle 90. So I assign my angle x here, just like it says tan x. So tan of the angle x. So remember that when we have so, This is what helps you remember the trigonometric ratio each time. So tan is equal to opposite over adjacent. So for this fraction, that means that this 5 is the opposite and then 12 is the adjacent of the angle. So we have opposite, which is 5 over adjacent, which is 12. Now this is the hypotenuse. The first thing we have to do is to look for the hypotenuse, because sine and cos all contain the hypotenuse. We must surely find the hypotenuse. Using Pythagoras theorem, we have that the hypotenuse, now what do I call this side, the hypotenuse? Let me just call it h. So h squared is equal to any other side squared plus the other side squared. We have that h is equal to the square root of 25 plus 144, which is equal to the square root of 169. We have that h is equal to 13. So the hypotenuse is equal to 13. Having seen this, we now get into the problem itself. This is always the preliminary thing to do. We have what is the value of sine x plus cos x? So we write out sine x plus cos x. Now sine x is equal to opposite over hypotenuse. Let me also label, this is hypotenuse, right? So this is the opposite. This is the adjacent. We have that sine x is equal to opposite over hypotenuse, which is 5 over 13. We bring down plus. Cos x is adjacent over hypotenuse. Adjacent 12 over hypotenuse 13. Now, it's easy to do. So this is just to solve the fractions. We have that since they have same denominator, we have 5 plus 12, which is equal to 17 over 13. Now we can reduce this to the lowest terms, giving us one whole number, 4 over 13. So any of these. Have you seen how we decompress, like this crazy stuff has come down to simple thing? Over to this next example. We have that if sine theta is equal to 5 over 13, find the value of 1 plus tan theta over 1 minus sine theta. Now, I know you know that this is already very simple. So the first thing we do is to draw a right angled triangle. Assign theta to one of these angles. We have that this is now the opposite. This is now the hypotenuse, the side opposite angle 90, and then the remaining side is the adjacent side. Now we also write out so given that sine theta is equal to 5 over 13, which is opposite over hypotenuse, we now say opposite over hypotenuse 13. Now we look for the adjacent side using the Pythagoras theorem that says that the hypotenuse squared is equal to the other side squared plus the other side squared. Let me just call it capital A squared. Now we have that A squared is equal to 13 squared minus 5 squared. We get the square root of both sides so that A is equal to 169 minus 25, that is 144, which is equal to 12. So we have the adjacent side is equal to 12. Now we go over to our major question, which is that 1 plus tan theta over 1 minus tan theta. So this is 1, we bring plus. Tan, that is opposite over adjacent. Tan theta is equal to opposite, which is 5, over adjacent, which is 12. So 1 plus 5 over 12 over 1 minus 5 over 12. Now we are going to solve the numerator and the denominator separately. We have for the numerator, or just simply, let's just say that 1 is 12 over 12. Just the denominator over itself, or let's get a common denominator for both of them, which is equal to 12, right? For the numerator, that is what we are solving here, 12. Okay, so any number is always over 1. So this is 1 over 1, which is 1, right? So the denominator 1, dividing into 12, that's 12 times 1. We have 12 plus 5, giving us 17 over 12. Then the numerator, the denominator, we have the LCM is still 12. So we have 12 minus 5, giving us 7 over 12. So we have this. Now let's have those fractions together. We have that 17 over 12 divided by 7 over 12. Now we have to convert this division sign to multiplication sign by saying 17 over 12 times 12 over 7. 12 cancels out 12. We have that 17 over 7 remains. Now we get this down to proper fraction, which is 2 whole number 3 over 7. That is our final answer. So you can see we started with a crazy looking question, and then we still follow the same method of derived trigonometric ratio problems, and then we are able to get down everything down to very simple things.